and somehow it just may not help. Uh, Brad, uh,
All right.
you're on. Introduce yourself and on with the show.
I'm Brad Nelson, uh, occasional fourthy person, and I'm going to talk today about uh, Forth Haiku, which is something I did a long while back, but occasionally we'll do sort of updates on it. And I thought today I would do a little bit of a tutorial. I think there's a different mix of folks who maybe haven't seen it, and I'm going to approach it with a bit of a Halloween theme. So um, Forth Haiku it's a website. It's a variation on the Forth language, specifically for generating images, and it is designed with the intention of making it really easy in a very small amount of code to produce an interesting image. And so you can explore it yourself at the URL above, forthsalon.appspot.com. I'll sort of briefly give you a sense of what it can do. So there's a set of top haikus here, and when I first put this together, I would not have imagined the range of imagery folks would post. A lot of these are posted by folks around the world, inside and outside this group. And so, this Pac-Man one was particularly impressive. There are animations. There are things that folks have done with 3D. There are sort of amazing sort of exercises of brevity and so on. But let me zoom back a bit and sort of explain what's going on with these and how you would generate an image like one of these. So the canvas that you have in Forth Haiku is a square, and this is because there's a coordinate system at play here. In the lower left-hand corner, it's 0, 0, and in the upper right-hand corner, it's 1, 1, so sort of a mathematical look at the world. And what you're doing in Forth Haiku is you're creating what some would term a pixel shader, which is a way to describe the set of pixels that make up a texture. This is a technique that's used in 3D graphics to produce sort of surface textures on objects. And the way this dialect of Forth works, it has a floating point return stack and data stack. And it has one other sort of peculiar quirk, which is that and this is due to the limitations of pixel shaders on graphics hardware, because what's happening as you enter one of these haikus, it's being converted into a pixel shader and has to meet those constraints. And that behavior is that the program needs to be run independently for every pixel in the image. And so, and the rule is that the outer code within the haiku is run once for each pixel, and the assumption is that there will be 3 or 4, up to 4 values on the data stack, and those correspond to red, green, blue, and optionally an alpha value. And if any of those are missing, they have a default assumed value. So, for example, if you put just a 1 on the stack, you get pure red. If you put a 0, you get black. But if you put all the RGB values there, so you put all ones, 3 ones, you get white. If you put 1, 1, 0, you get yellow. If you wanted to get orange, you could do a little bit of all red, half green, a little bit of no blue, and you get orange. So far you get colors. If you but there are some interesting special words that are available to you. So if you have the word X, X gives you the X coordinate at the current pixel. And so with just X on the stack, you're leaving just one value there for the red component, and it varies as you go from 0 all the way over to 1. And so you get a gradient in the x direction. If you do y, you get you're leaving a single value on the stack, and you get a gradient going from 0 to 1 in the y direction. And you could leave both x and y there, so you're leaving a red value that's varying in x and a green value that's varying in y, and now you get an interesting gradient. Another special word that's present is t, and this is how we get animations. And so on its own, t varies from I believe it's 0 to the number of seconds in a day. So it's the units are seconds, and then it wraps around each day. And so on its own, it's out of range. You know, it's at least this time, unless you're right at midnight, it's going to be much bigger than 1. But for example, you could do 1 time 1 mod, and then you will get an oscillation that varies in time, like so. You can, let's do a little bit of other simple ones. Let's say you have, so there are all the major math operations, and unlike sort of typical Forth where you would have like an F in front of all the floating point words, for simplicity, I've sort of stripped that off. So the sign of x on its own is not particularly interesting, kind of it looks a little bit like x. But if you say put y on the stack, and you say we're interested in the places where the sign of x is less than y, then you get a curve. And you can, for example, increase the frequency here by multiplying x by 20 before you take that sign, and then you get faster oscillations. So you can use this to, and then if let's say we add time into x, and then you get horizontal movement. So let's try to use this to build some interesting Halloween style shapes. So I'm going to start with and please, if you have questions, feel free to interrupt me. The intention is to sort of convey the ideas, and I've got a few Halloween examples as a kind of a motivating set of examples, but I'm eager to answer questions if folks have them.
Sorry to be off in left field, and I should probably know this already, but where is the processing taking place? Where is the code?
That's a great question. So the processing is actually taking place within your own web browser. So it's not happening, although it is possible when you're all done, and I haven't shown this part, to publish your work, and you can take credit for it and all of that. That's just saving a copy in a database on the server. The Forth program is actually executing on your system, and if you have an external graphics card, it will run on that graphics card. If you have a regular CPU, it will sometimes be a combination of the CPU sort of doing it, and then using whatever the limitations of if you have like integrated graphics or something. And so what's happening is that your program is being converted to actually first to JavaScript, then I do a conversion from there into a variant of C that is used on the web to do a WebGL shader, and then it's actually being run locally on the device. Does that make sense? And that's actually how it's able to be so fast, because it's actually getting optimized quite a bit by the optimizer that's in the GPU driver, and it's also taking, if you have a nice GPU, it's actually taking advantage of quite a lot of parallelism that is available in GPUs. So I'm going to put in the following shape. So let's go back to that sine curve and I'm going to try to build something that looks like a gravestone. And so let's suppose that I have just a sine curve, and I look at where it's greater than y. well, I get this kind of interesting bump, and that's not quite right. But remember that the sine has a period that's related to pi. So let's multiply x by pi, and then we get something like that. But that's not quite right for a gravestone. You want it to I guess it could be a kind of an unusual looking gravestone. But let's raise this to a fractional power. So actually, let's see what happens if we square it first. So if we square it, it gets even narrower, and that's not the direction we want. And in fact, if we go even further, right, it gets really, really peaky. So let's go the other direction. Let's make it the square root. That's pretty good. Let's do even a little more, and then it looks kind of like a gravestone. So that's great. And then we can do dupe to put it in, copy that red value into green and blue, but that'll be white. So we want something a little more gray. So let's first multiply by 0.5 and then duplicate it twice, and now we got a gray gravestone. So that's our we can even put that in here, gravestone. And I can take some credit for that and put it in there and hit publish, and it will show up here in recent haikus. But let's say I want to improve it a little. I want to it looks a little bit plain, so let's give it a little bit of embellishment. We can click on what's called create a derived work, and it will give us back our code here. And let's try to give it sort of an interesting texture on the surface. So what I'm going to do is, before we copy the red component to each of the red, green, blue channels, why don't we mush together a bunch of, say, a cosine of 20 times x, and maybe pick some arbitrary values here that y times 11y sine. Let's add that. So if we do that on its own, that's going to be too many things in the stack. But we can what we could do is multiply that by some smaller number, 0.2, and then add that in, and that'll give us a little bit of texture. That's a little bit too regular, so maybe let's add in one more component here. How about we do, and we have to do it before we scale it there. So let's add in, maybe take x plus y, multiply that by 7, and take the cosine of that, and then add that into the mix as well. And that gives us a little something. So we can call that gravestone redux. And we could take credit for that too. So that's the sort of core idea, is that you can sort of build things up, and that's typically how I will build these. I'm sure that some of the folks that build these very elaborate ones have their methodology to it, but I'm going to walk you through mine. Any questions at that point? I'm going to do another one if folks are.
So if I wanted to get started from scratch,
Yep.
would I just go to the salon and go from there? Or is there a YouTube video that you did in the past that says, okay, here's step one?
I think we've.
Or do I wait till fourth day when you're going to do one?
So I've tried a few tutorials in the past, and I think that I certainly could try again. I think one of the things that I think I would encourage folks to do is think about it a little bit like maybe playing with some oscillators and an oscilloscope. And to really get a sense of what you can do, you kind of have to play around with it and say, oh, well, let's say I had x, and if I just did multiply x by 20, I get this thing. Well, that gets clipped, so maybe I'll mod that, and then you can sort of mix and match functions, and you quickly get an instinct. And I was surprised by this myself when I first kind of came up with the notion. I thought maybe there'd be some interesting simple gradients that you could do that would be beautiful. But I quickly, discovered, and others online, I think, found that a lot of the mathematical operations, when you compose them, you get interesting effects. If you I guess I would say, on the one hand, yeah, there are some videos that I've made in the past, and probably could search on YouTube. Happy to try again with a tutorial, but I think the best sort of remedy is to go and interactively try it. Is that
Okay, great.
okay?
So then the tutorial part of that won't be present at Fourth Day. You just have to wing it, or at least look for one of Brad's previous talks where he describes. Okay, so step one is to go to forthsalon.appspot.com or do a googly search for the Forth Haiku.
Mm-hmm. Yeah.
I have to comment. Brad, that this is very APL-ish.
Mm-hmm.
That this is essentially APL over a limited domain, and yes, enough said. I mean that would be beautiful to go and see, and the fact that you know how to go and make this run very rapidly on essentially web service. Wow.
Well, let me go ahead and try another one here, just to give folks a sense. And that part of my goal here was sort of that tutorial. So I'm gonna do let's try to do some candy corn. So I actually despise candy corn. I think it's one of the most dreadful Halloween candies, but it has a particular look to it. So let's first thing we got to do is get a curve that we can use to give us that characteristic sort of shape to the candy corn. I don't know if I'll do a stellar job, but let's do something a little bit like what we did before. And let's so we got to get a curve here, and we'll use a cosine to give us that shape on top. So we clip it where to be above a certain value. And then, just like we did before with the top of the gravestone, let's raise it to a power and see what it does to the shape. So I'll count that as good enough. And then let's take a similar curve, and maybe we'll raise it to a different power. And then if we do that, right, we're just going to get an outer envelope. But let's flip y around. So we'll say 1 minus y, and then that will sort of flip that down to the bottom. And so you get these two masks, one in the red plane and one in the green plane, and we can AND them together. So we get this sort of a silhouette. And I didn't mention this before, but of course, you can define words as well. And so let's call this a mask, and the mask is going to leave one value on the stack here, and that will allow us to more conveniently make reference to it. So we can, if we do mask, 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 we get the same thing in white. But what we want to do is actually kind of add the stripes on. And so in the red plane, we're going to want, all red there. But in the green plane, it's actually kind of tricky, because we're going to want to do, we're going to want to have a sort of a bar down the middle. So let's think about where that bar needs to go. So we could say that it's where y is greater than 0.3 and where y is less than 0.8. So if we see those just initially in, we're seeing them in red and green, that's hard to see. So let's AND those two together. So now we're seeing in green the band that we would be pulling out. And then what we want to do with that is, of course, combine that with the mask. So we'll put the mask in there and multiply the two together. So that limits it to that range. But the yellow on the candy corn actually goes in the bottom. So what we're going to want to do is actually have the whole thing there And then let's actually subtract off. We'll do negative 0.6 times that and add those two together, and that will pull out. Let's see, is that that looks a little weird. Let's see. Yeah, that's right. And then so that'll give us something off here. Let's see. There we go. So that'll give us a band in the middle there, and then let's work on the blue plane. The blue plane, we just need to make the tip of the candy corn white, and so for that we'll do y compared to 0.8, where it's greater than 0.8. We'll AND that with the mask, and so then that gives us the candy corn. Candy corn. Any questions about that one?
That's fantastic. I love that. That's great.
All right. Okay, let's try. Next, I've got let's build a scythe here, and so we'll take the x value, and let's maybe do 2 times x and a cosine, and then if we look at that, maybe scaled by 0.3. And add in a 0.7, and then look where that's greater than y. That gives us some kind of a curve there, and that to my eye looks at least roughly like the top of the blade. And then let's take a cosine, and we'll do 0.3 times that, and a 0.5 plus that, and compare that to y, and look at what we get. And that's not quite right for the. I want my scythe to go out a little further. So let's take the cube of the cosine, and that carries it down to give it a nice shape. And then I'm going to want to leave some room for the handle. So actually, we'll deal with the handle in a minute. So let's take those 2 pieces, and we'll AND those together. And that's a neat little building block for the blade. So let's call that I'm going to have the. Actually, hold on. So we got the blade, and then why don't we have the handle? So for the handle. Let's have another mask where we just look at the. Oops, I did an AND here. Where we just look at the where the blade is. Oops, let's do less than. Where the blade is on the left here, and why don't we take the. So we want the handle to have a little bit of texture to it. So let's take. Let's have it vary in y, and then maybe take the sine of that, and then add in x to give it a gradient, and let's multiply those two. Ooh, that looks a little bit weird. Sorry. Let's do. Why don't we do? Let's actually first do. Here's what we'll do. We'll do less than that, and then we'll do 30 times the cosine to give us that bar. Okay, so we got a bar, but we're going to want to have these 2 parts kind of overlay. So we'll need to cut out the silhouette of the handle from the other one. So if we do that, now we've left the two pieces there. And then so and then what I had hoped to do earlier is let's put a little texture on the put a little bit of texture on the blade itself. So we'll take this gradient and multiply it in, and that'll give just a little bit of shine to the blade. And let's give a name to that whole thing. We'll call it parts and it'll be the parts of the blade, and that puts two values on the stack that we can then use to actually now assemble our pieces. So for the red plane, we'll just add them together so that we get both pieces. And maybe we'll multiply it by 0.8 so it's not quite so bright. And then for the green plane, we'll maybe multiply the handle part, which is the top one on the stack, because the parts here, what it's doing is it's leaving the blade and then the handle on the stack. So we'll scale the handle down so that it's a little bit more brown, and we'll use that same 0.8 so that we get, because we're going for kind of a silver, white gray blade. So that gives us the brown, and then we've got a yellow blade, and so then all we need is now for we'll just drop the handle, because the handle looks fine, it's brown, and then we still want that same 0.8, and that will give us our scythe. Cool. All right, now we'll see if I can spell scythe. Okay. How are we doing on time, Kevin? I've got a bank of additional ones, but I also want to be mindful of.
You imply a level of organization that is clearly not present. I would think that if you are done by 11:30, everyone concerned will be happy.
Okay.
I think does that suit you?
Sounds good. I got a bunch of them here, so I can just try to pull from the bank. All right, so let's do a little bit trickier one, but in some ways, as you'll see, trickier doesn't necessarily mean bigger. So let me show you a trick that I will often use when I am building up haikus, which is that a nice thing about Forth is, of course, you can redefine everything, and that includes in haiku Forth, you can redefine even the core words. And so you can redefine x to be x minus 0.5, and that recenters the origin. And so for example, let's say we have a gradient here just to illustrate that. You'll see that x and y are now, whoops, I've had this. You'll see that they start a little further up, and they range from negative 0.5 to positive 0.5. And then that'll let us do some interesting things with the origin being in the center. And so what we can do is we can take x and y and take the arctan2, which will find the angle based on 2x and y values. And to give you an idea what that does, now you get sort of something that varies around in a circle. And then similarly, we can calculate the distance from the center. And so we can what we can do is we can do the x value times itself and the y value times itself, and we add the two together and then take the square root, and that gives us the distance. So if we look at the distance, it gets bigger as you go away from the center. And then what we can do is, let's say, as we do the angle, let's multiply it by some big number, 20, and take the cosine of that, and that will give us a sort of a starburst pattern. But let's make that a little sharper by raising it to some power, and that gives us sort of even tighter lines. And then we can do the same thing with the distance curve. We can maybe multiply that by 70, and let's also take the cosine, and then also raise it to the 10th power. And then that gives us this sort of superimposed sort of set of rings, because we're seeing the pulses in that sine wave that we've raised to a certain power. And but let's take the maximum of those two values. So we'll get the places where they overlap and merge them. And that's starting to look a little bit like a spider web. But let's trim it so that it has a kind of a nice edge. And we'll take the distance and maybe let's say 0.5, and we'll look at where that's less than, or where the distance is less than 0.5, and we'll multiply that. And that's okay, but let's make it a little bit tighter so that we get that neat edge there. And then we'll duplicate that in green and blue, and we've got ourselves a spider web. Cool. Okay.
That's awesome.
All right. Let's see. Let's do some cat's eyes. So we'll use some of the same tricks that we used before, but we'll mix it up a little. So one thing that we'll do is we'll mess with the coordinate system again. So as before, we could recenter at x at 0.5. But cat's eyes are symmetrical around the center. So let's just make the coordinate system take the absolute value so that it repeats itself. So to give you an idea what that looks like. Now as the x value varies, there's a mirror, imaginary mirror sort of in the x direction. And then we're going to need a couple different utilities. We'll do square, which does that, and then I'm going to just call distance d. And unlike last time where we did distance from the origin, let's do distance from a particular point that gets passed in. So you'll compute the distance there. So that's a little trickier. You take the y value minus the first value on the stack, and you square it, and then you swap that, and you take x minus the other value, and you square that, and so sum of the squares, and then square root, and then let's try to build up the kind of silhouette that we would want for cat's eyes. So we'll do. I'm going to pick out some values here, and let's take a look at what that gives us. We're taking the from a center at 0.2 and 0.5, we're getting a certain distance, and so that's giving us. We would normally have gotten, without this line, if I commented it out, we would get one circle, but instead, because we sort of put that mirror in the center, we're getting two circles. And then let's intersect that with another set of circles. So we'll maybe use these two, and we'll AND them together, and that will give us sort of cat's eyes, right? But those look like regular eyes. So what if we mess with the y coordinates a little bit more? So we'll take the y coordinates, and maybe let's add in the sine of the x coordinate and scale that by 0.2, and then subtract it. Actually, let's see what happens if we add it. So if we add it, it sort of groups the whole coordinate space is squished down in y. But if we subtract it, then it pops it up like that. And then we can turn that into a mask that we combine. And let's actually make it something where we pass in a value and apply the mask to it, so that we're sort of masking out something. And so then if we had one mask, we get the same thing back out. But if we had 0.5 mask, we get that, or if we had x, we get that. And so that lets us mush together some spooky stuff. And so now we just need to come up with a kind of a cool eye-like gradient to put in there. And so I'll stick in again just kind of a smush of different sines and cosines, and So maybe we'll have a little bit of oscillation like that, and then we'll do something like this, and we'll just make up some numbers. And then we'll, oops, and I've got too many values on the stack. And then let's see what that looks like. So that's pretty good. Why did we get the mask there? That's kind of, oh, because I pulled out the silhouette. Oh, that's for later. All right, so let's mask that and see what we get. So that's starting to look a little bit like something. But what I wanted to add into that was this this eyeball piece of it, which looks like that, and that's pretty good. But a cat's eyes are kind of more narrow, so I'm going to make a different version of this distance function that takes, I'll call it new distance, that takes a scaling factor, and then the scaling factor, I'll stick it in so that we multiply by that scaling factor, and that will let me squish. Oops, that will let me squish the eyeball together if I put in this new distance function. So that looks a little bit like spooky cat's eyes, and then similar idea. I'll pull the canned one off the shelf here, but you could do something like that that's slightly different in the green plane to give you the green plane, and then maybe for the blue plane we do something a little simpler like that. Give it just a little hint of something. So that's cat's eyes. Glancing over at the clock, and do again interrupt me if any of those are.
So, can I try to explain how I'm thinking it through and tell me where I'm wrong?
Sure.
So what I'm seeing it as, how I'm imagining it, is you're writing, a fourth program. That program is going to basically turn into a word that takes an X and Y coordinate and a time, and then returns whatever RGB values, so three values that should be at each individual pixel, and that just gets applied across the plane, and it's very fast.
Yep, exactly.
Oh, that's cool.
Yeah.
Okay, that's just making sure I'm tracking. I really like the idea.
Cool. Let's see. Looking at the clock here. Well, I'll tell you what. So I've got a couple of other canned ones, but let me go ahead and rather than, I won't explain the details of some of these, but let me instead talk about some of their interesting points to sort of use up the time. So we didn't use time much here, and so one of the things that we can do here is we can put in something that involves time. And so this one is just sort of a bunch of slime going along, and the way that it incorporates time is that it's oops, let's see. So if you look here, what I've done is I've just added in this little bit of oscillation on top of what was previously just this. So all I'm doing is I'm taking that Y value where I had clipped the curve, and I'm adding in, or rather subtracting, the sign of the time, and that gives it that extra oscillation. And then the background there, the green isn't as obvious, but I had a second layer where I have just this actually. Sorry, just that much of it. No, that's still not right. That no, where's the mask? Oh, I see. Yeah, it's getting just superimposed. So, so anyways, that's we'll call that one slime, and cool. Let's see. So here's one. It uses some of the same tricks that we did before. It's remapping the coordinate system. It's using that same distance operation, and it's just using it to carve out some circles out of a space. So there's really just if we comment out the bottom here, we're starting with just that, and then superimposing that on top of it, and then doing a carve out one by one for each of the different pieces, and then down at the, and then right before the, and then so we get the thing all in red, and then add that, and then copy it with some scaling factors into the plane. And one of the neat things that ends up happening is that even if you have values that go out of range, they go higher than 1, that can be useful if you copy them into other planes and then add a scaling factor. So that's, we'll say that's spooky face. But another thing that you can do, and let's create a derived work here, is you can add stuff on top, and you can do that by sort of taking what you already placed on the stack, and you'll see this in a bunch of other haikus. There's some recipes that folks will kind of copy around, and this one is just sort of adding a bit of a checkerboard layer superimposed on top, and so it moves along with the other one because the movement is up here in the warping of the space, and so then you get this sort of variation. And so you'll find at the tops and bottoms, the top of some of these things that warp the coordinate space, and then at the bottom things that superimpose stuff. So we did the pumpkin, we did the side, did the gravestone. I'll throw it out there because I actually forget what this one looks like, but here's a ghost. And so this one has a bunch of different things going on here. Basically, it also has a sort of a superimposed layer at the end, like we were just mentioning. So on its own, it's just a bunch of superimposed cosine curves and circles that were carved out, and then this other blue layer is an oscillation, but there's actually some negative values that you only see when they pass over the ghost. So we'll call this ghost, and we did the cat's eyes. Let's do one other thing we can do. Maybe we'll do it to the cat's eyes. Is that we can also take the mouse into account, and this is, you'll see there's an interactivity option. If you use MX, it will be the position of the mouse cursor, and you can use that to warp the coordinate space. So here I'm just adding in a little bit of warping before anything else happens, and so I can now move my mouse around and wiggle the eyes. So that'll be rather wiggly cat's eyes. So that trick you can play on a bunch of them. And there, let's see, we did the broom. Let's see, I'll show a very terse one. Here was my attempt at some witches' brooms. It's not great, but this one is kind of one of these pithy, packed ones, trying to be kind of down. Originally, I had this idea if you would actually shoot to try to have it be in a haiku structure, but and I think I have, this is the last one, I believe. So we did cat's eyes, ghost, pumpkin thing, candy corn, cool. All right, and my last one is just a cauldron. And again, this is some of the same tricks. Warping the coordinate space at the top, coming up with an operation for distance, and then I use that to create a bunch of masks that are used to cut out the edge of the lip, and then I just have some smush of functions. There's a couple of words, if you look in the glossary, and that's actually another good guide down here. There's a link to the Forth Haiku glossary. And there's some words for doing complex multiply. And so I'm using that as a quick way to get the smush. And you'll see that sort of repeated in some of the haikus. So that's the cauldron. And with that, I think I have exhausted my pre-canned stuff. And if there are any remaining questions or comments, otherwise I'll pass it back to you, Kevin.
All right. The silence was deafening. Anyone else? Going once, going twice?
You're muted, Kevin.
I was unmuted for a second there, and somehow I got muted again. Go figure. So Don sent a note. I think this is the note that he meant to be communicated to you. Don Golding, currently in the middle of his AI board project, says, I plan on giving an expanded version of this talk from Forth Day. I think that refers to his AI talk that he gave for reference. Contact on or wait till Forth Day. He says he hasn't quite gotten the FPGA to program yet. As soon as this is working, limited boards will be available to developers. If you're interested in participating, I encourage you to contact Don. It says, I will do a production run in January or February of next year. After Forth Day, I expect to have new material every month in 2024. He says he also wants to start classes and workshops next year, even thinking of a virtual conference for IoT and AI. So I'm reminded that the president is issuing an executive order for the rules for dealing with AI, and all I can say is, what can go wrong? I welcome the day of our robot overlords, when without belaboring it,